And then we're going to start with another part for 35. Okay? Now for 35, we're going to do the same thing. Right? What can we do here? We know that if these two, then these are congruent, right?
Perpendicular.
Now, and this is perpendicular too, right? So we have what's called a perpendicular bisector. Okay? We also have, if these two are perpendicular, or these two are congruent, then these two are congruent. Why?
Angle side to side.
We'll get to that part, but first, if these two are congruent, these two are congruent, why? Why are those two congruent?
Definition of congruency.
No, we just talked about it. Remember? It's the converse of the bisecting angle theorem, right? The bisecting angle theorem. That one that says, if I bisect this angle, then the two opposite sides are congruent. Remember that? If the two opposite sides are congruent, then then this angle is bisected. That's that converse one. And then I know that these are congruent. I also know these are congruent because of the definition of, like he said, perpendicular, right? So now I have side, angle, angle. Is that one of our... Yeah, angle, side, right? So angle, side is one of our triangle congruencies, right? That means that CPCTC works. Which means that these have to be congruent, right? Okay? Now, if this is... How much is this? Is this 5? Did we already...
Yeah.
How do we know that?
And those side angles are...
Oh, that's my side. Okay. That's my side. Okay. It's not 5. Alright, so I'm like, how did we get that? Alright. So all we really know is... Let's do this in color. Alright, we know this... And we know this, right? And we know that this is a right angle, so we can do Pythagorean Theorem. Now, is this a Pythagorean triple?
No.
Well, let's think. Does 5 go into 30? How many times? 6. So that would be 5 times 6, right? Okay. Does 6 go into 18? How many times?
3.
6 times 3, right? That's good. Because we have a 3, 4, 5 triangle. So 6 times what? 6 times 4 is what? If this is a 4 triangle, then it's 6 times 4, which is how much?
24.
24. Okay? So we know, because of the Pythagorean triple, right? That we have, this is 4 times 6. Remember? Because we have the 3, 4, 5 triangle. Okay? And it's 3 times 6, 4 times 6, 5 times 6. Does that make sense?
I don't know how you got 4 times 6.
Well, we said, hey, how many times does 6 go into 18? 3 times. How many times does 5 go into 30? 6 times. So we knew that it's 3 times 6 and 5 times 6, right? And if it's going to be a 3, 4, 5, then it has to be multiplied by the same amount. So since it's 6 times 3 and 6 times 5, if this is going to be a 4, it has to be 6 times 4. Does that make sense? They're all going to be multiplied by the same amount. 6 times 5, 6 times 3, 6 times 4. Okay? So they're always multiplied by the same amount in a Pythagorean triple. Okay? And so that's how I got 24. Was I said, well, I see that this is divisible by 5 6 times. Now, I want to see, does 6 go into 18? Yes, it does, 3 times. Is 3 one of our Pythagorean triples, 3 and 5? It is. It's 3, 5, and 4. That's how I came up with 4, right? So then I said if it's 6 times 3 and 6 times 5, it has to be 6 times 4. Does that make sense? Okay? Alright, so, hey, if this is 24, and these two are it's a bisector, right? So it's cut in half. Then how much is this and how much is this? Right? So this is a midpoint, right? Definition of a midpoint says that if this is 24 from here to here, right? Then this has to be 12 and 12, right? And by definition of congruency, then what does this have to be? 12. Okay? Now, is this another Pythagorean triple? What goes into 18? Does 3 or 4 go into 18? Does 3 or 4? Because it's a side. So does 3 or 4 go into 18? 3. Right? Uh-oh, that's not good. Because that's 6, right?
4.
4! Well, that doesn't go into 18. Well, that's not good either. Right? So we might have to actually break this down into... It might work. Does anything go into them like these? A 5 and a 12, a 7 and 8. I don't see anything. So we might actually have to plug this in. 18 squared plus 12 squared, right, is equal to x squared. Okay? And then what is 18 squared? Well, 12 squared is 144. We know that one. 18 squared, isn't that 64? So, huh? 324, that's right. Alright, and so we add those two up, and that's 8, and that's 6, and that's 468. Is that right? Okay, equals x squared. And so we're going to break down 468. And that's a big freaking number, but we can do it. We start with 2's. And that's going to be 2, 3, 4. That's going to be 1, 2, and then this is a 1 and a 4 is 7. 2 doesn't go into 127. 3 doesn't go into 127. Does 4 go into 1? Or, does 5? No. Does 7? Well, that'd be, no. Does 11? No. And 11 squared is 121. So we're there. We're done. So the only thing that goes in there is 127. Is there a pair somewhere?
That's supposed to be 117.
Oops. Well, that's different then. 117. That is divisible by 3. Right? Sorry about that. Because that goes in one time. So 117. 1 plus 1 is 2 plus 7 is 9. Right? So that's divisible by 3. 3 goes into 11. 3 times with 2 left over. 3 goes into 27. 9 times. Does 3 go into 39? Yeah. Once and 3. And then 13. Alright, where's our pairs? We have a pair of 2's and a pair of 3's. So we take out a 2, we take out a 3, we leave in the bottom.